Let's do some heat problems. Remember, heat is Q, and that's mc delta T. Remember, delta T is going to be your final temperature minus your initial temperature. Mass is usually going to be measured in grams. C is your specific heat, and it's usually going to be in calories per gram Celsius. T, of course, is going to be measured in Celsius, and Q, heat. Well, if this is our specific heat, it's going to be measured in calories. It can also be measured in joules. Remember that when you take shot and put it in another container at another temperature and you're looking for thermal equilibrium, that the heat lost has got to equal the heat gained. Now, suppose you have a beaker of water that has 300 grams of water and it's heated. Well, 300 grams is going to be the mass, so M is 300 grams. And the temperature rises from 30 Celsius, so this is your initial temperature, to 90 Celsius. This is obviously going to be my final temperature. How many calories, so this is the heat, did it take to heat the water? And you'll see I was given C as 1 calorie per gram Celsius. Now, could I have used C as 4.2 joules? That conversion, yes, I could have, but by using this one, I'm going to get the answer in calories. The first thing I'm going to do is find delta T. Delta T is T final minus T initial. So T final is 90 Celsius minus 30 Celsius. So delta T is 60 Celsius. So the heat, Q, is mc delta T. The mass is 300 grams. C is 1 calorie per gram Celsius times delta T, and in this case delta T, I just found it is 60 Celsius. Now I'm going to check my units here real quick. This is over 1 and this is over 1. So I'll multiply straight across. So grams is in the numerator and the denominator. Celsius is in the denominator and numerator. So I'm left with calories. So those are going to be my units. So 300 times 60 is 18,000 calories divided by 1. So there's my answer. Q is 18,000 calories. Now, what mass of water? So I'm looking for mass. What mass of water will give up 240 calories of heat? Okay, I know immediately that's Q. When its temperature drops from, so T initial is 80 and T final is 68. Well, let's see if we can do this calculation. I'm looking for mass, and it gives up 240 calories. So Q is 240 calories. The temperature drops. T initial is 80 Celsius, and T final is 68 Celsius. We don't usually put the degrees on the Celsius there. Now, it says the water gives up 240 calories, and that tells me my Q is going to be negative. Just a small point. First thing I want you to do is find delta T. Delta T is T final minus T initial. So this is 68 Celsius minus 80 Celsius, or negative 12 Celsius. Don't let that negative sign upset you. It's just, it's in line with the fact that I'm going to lose heat. Now I'm forgetting something. I need my heat, specific heat for water. So C for water, I know is 1 calorie per gram Celsius. Now I use the calorie one because I was told that my heat was in calories. So Q is mc delta T. Now I'm looking for M. So I divide both sides through by C delta T. So when I rearrange this, I get that the mass is Q divided by C delta T. Now I'm going to plug in. Q is negative 240 calories. I'm going to put parentheses around this because I've got some big denominator coming up. C is 1 calorie per gram Celsius. And delta T is negative 12 Celsius. Now I'm going to cross out my units. Calories, it's going to cancel. I've got a Celsius in the denominator here and here, so those are going to cancel. Now what I've got is a 1 over, a 1 over, 1 over. So that's going to leave me with grams. So it turns out my units are correct. So I multiply straight across. When I multiply straight across, all I get is negative 240 divided by negative 12. And the grams are going to wind up being in the numerator. So 240 divided by 12, the negative signs will cancel, gives me 20 grams. Now, a 30-gram piece of iron, so there's my mass, is heated to 100 degrees and cools to 30 degrees. Okay, if iron specific heat is 0.11, how many calories does it lose? Now, this one's a little tricky with the wording because this is my initial temperature. All right, my initial temperature is 100. Oh, lost it. And my final temperature is 30 because it starts at 100 and cools down to 30. And now I know the specific heat is 0.11. Let me write out my givens here. This is kind of messy. Mass is 30 grams. T initial is 100 Celsius. T final is 30 Celsius. And the specific heat is 0.11 calories per gram Celsius. And I'm looking for how many calories. So how many calories is Q? Let me first find delta T. Good thing to always do to start with. This is T final minus T initial. So this is 30 Celsius minus 100 Celsius, or negative 70 Celsius. So Q is MC delta T. The mass is 30 grams. C is 0.11 calories per gram Celsius. And delta T is negative 70. And don't worry about that negative sign. I'm going to check my units real quick. Grams in the numerator. Celsius goes away. I'm left with calories. Now I'm going to put all this over 1 and multiply straight across. So do one thing at a time. 30 times 0.11 is 3.3. And then this is going to be times negative 70, and this is all over 1. So 3.3 times negative 70 is negative 231 calories. Now, what does this negative sign mean? It just means that I lost heat. So how many calories, the actual number of calories is 231 calories. Now for this one, I have a 50-gram piece of aluminum at 100 Celsius and put in a beaker of water. It loses 735 calories of heat as it cools to 30. And I want to find the specific heat of aluminum. Let's see. 50 grams is mass. This is my initial temperature. This is the heat that's lost. And this is my final temperature. So let's see. M is 50 grams. T initial is 100 Celsius. I'm going to put T final here. Is 30 Celsius. And Q is 735 calories. Let's find change in temperature. It's always T final minus T initial. So this is 30 minus 100, or negative 70 Celsius, excuse me. So let's see, Q is MC delta T. And this time I'm solving for C. So I need to divide both sides through by M delta T. So for this one, the specific heat is going to equal the heat loss divided by M delta T. Now, it says I lost 735, and I always forget that negative sign. You're going to need it in a minute or I'll get a negative C. Let's see. Q is negative 735 calories. M is 50 grams. And delta T is negative 70. Well, let me, first of all, I see my units are going to be, let me circle them here, calories per gram Celsius. That's really good. That's what we've been using for specific heat. Let me multiply straight across. This is negative 735 calories in the numerator. And then 50 times 70 is 3500. And this is grams Celsius. And it's negative because that negative sign right there. Now 735 divided by 3,500 tells me that this is 0.21 calories per gram Celsius. Now this one's a little bit more complicated. We're looking for the final temperature of a mixture. I have a 100-gram brass block at 90 Celsius. It's put in a styrofoam container containing 200 grams of water at 20 Celsius. Assume no heat is lost to the surrounding. What's the final temperature of the mixture? Let me do this by breaking it into colors. Okay, the brass is 100 grams and it starts at 90 Celsius. Okay, and then C for the brass is right here. So I'm going to put all the brass over here. Okay, so the mass of the brass is 100 grams. T, and I'm going to put a hot here. Let's do TB, is equal to 90 Celsius. And C for the brass is 0.378 joules per gram Celsius. Now I'm going to come over here and in blue put everything for water. Okay, so here's the water. So the mass of the water is 200 grams. And the water starts at 20 Celsius. And I know C for water is 4.18 joules gram Celsius. I told you this was going to wind up coming up. We want it all in joules, so this is okay. Now, let me show you what happens. Which one of these is the hot one and which one of these is a cold one? Clearly the brass starts off hotter and it cools off. So the water is going to be the one gaining heat, while the brass is going to be the one losing heat. This is kind of important. So let me just do it this way. Heat lost has to equal the heat gained. Now, what is the heat lost? It's the mass of the brass times C of the brass times delta T. Now, the delta T is going to be, let's see, I want the higher temperature first. So it's going to be the temperature of the brass minus the final temperature. And I'm just going to leave that as T. And this has to equal heat gained. And the heat gained, and I'm going to have to make another side over here, is mass of the water, C of water, times. Now, this is going to gain heat, so its final temperature is going to be higher. All right. Now, what I'm going to do is I'm just going to multiply this whole mess out and write it down here. And I will do it in the colors. So I've got mass of brass, C of brass, times T of brass. Mass of brass, C of brass, T of brass. And it's going to be minus, because I've got to take this whole thing and multiply by both terms. So minus mass of brass, C of brass, times the final temperature. And this has to equal this side here. So now this, I'm going to multiply both of these by them. Mass of water, C of water, final temperature, minus mass of water, C of water, T of water. Now I know this is messy. Just hang in there. Okay, what I want to do is get all my final temperatures on one side and all my water and brass temperatures on the other. So I'm going to do this. First thing I'm going to do is add. Basically, if it's negative, I'm going to add it. I'm going to add mass of brass, C of brass, T, to both sides. All right. And then I'm going to subtract, I'm going to add mass of water, C of water, T of water to both sides as well. Do you see what I did? All right. These two are going to cancel. Those are going to go away. And these two are going to go away. Now I'm just going to rewrite this. This is mass of brass, C of brass, T of brass, plus mass of water, C of water, T of water. And this has to equal. Now look at this. I've got a T here. This whole thing over here is 0. It's going to be the final temperature times mass of water, T of water, plus mass of brass, C of brass. God, this is ugly. Let me switch pen colors because I can't see this. So the final temperature is going to be mass of the brass, C of brass, T of brass. This is the initial heat of brass, plus mass of water, C of water, T of water, divided by, now I'm going to divide by this big mess here, mass of water, C of water, plus mass of brass, C of brass. Ah, what a mess. I know it's ugly. Hang in there. Just plug in. If you've gotten it organized, you can probably come over here and do these calculations separate. It might make it a little easier. I'm about to run out of room. Let's see. The mass of the brass, I'm not going to try and put my units in here because it's going to be too small. So this is 100. C of brass is 0.378 times the initial temperature of brass, which is 90, plus mass of the water, which is 200, times 20, times C. And this is all going to be divided by, let's see, mass of water, C of water, mass of water, C of water. This is 200 times 4.18. I need parentheses there. Plus mass of brass, which is 100, times C of brass, which is 0.378. Now I know this is a lot of numbers. So what I'm going to do is I'm going to circle them in colors. Multiply these numbers right here together. All right. 100 times 0.378 times 90 is ugly, but it's doable. So this is equal to 3402. And we're going to add to that. Now I'm going to switch colors here. This one's going to be brown. 200 times 20 times 4.18 is, oh, it's a big number. 16720. And this whole thing's going to be divided by this mess here. I'm sorry I ran out of room. Let's see. 200 times 4.18 is, I don't know, 836 plus 100. Let me do this one right here, and oh, let's go to light blue here. Oh, I guess that one's back in brown. 100 times 0.378 is 37.8. Now, we're going to get through this. We're going to add these two numbers right here together. All right, and I'm going to switch it to black because I'm not going to be able to see it. All right, 3402 plus 16720 is a big number, 20122. And that's going to be divided by 836 plus 37.8. All right, so now we're going to add these two numbers right here together. And we got 873.8. Okay, now when I divide 20122 by 873.8, I get an answer of 23.02, oh my gosh, 8 Celsius, which, lo and behold, miracle of miracles, that's the answer. I know it's ugly, but just step through it. Make a column. All right. Set Q lost equal to Q gained. Figure out which one gains heat. The one that gains heat will have T first, and then its temperature second. The one that loses heat will have its temperature first and the final temperature second. And by the way, if you mess this up and you get them totally backwards, it'll work out. You'll just have an extra negative number that'll cancel out. Then distribute across. Get all of the unknown temperatures on one side, divide, and then plug. And it's ugly, but you can do this. These are fun problems. Just think of it like that.